Hello, everybody. Welcome back. It's Mo again. Well, in this lecture, we're going to be looking at is what is the difference between a broadcast domain and a collision domain? Like, what's broadcast? What is a collision? Watch this. I'm going to go ahead and open a new one and let's take a look. Back in the days, we had devices called hubs. Look at this. This is a hub. So I'm going to get myself a hub right over here and I'm going to get myself an actual switch. And here's a switch. Okay, so I'm gonna have a hub. I'm gonna have an actual switch. The first thing I want to talk about is what is a collision domain. Now, if I get online and I say, how do I know a hub versus a switch? So if I say, let's say, for example, let me scroll down over here. Let me go back a moment and go to images and right over here. You see this device over here, when you have a square, two arrows to the left and two arrows to the right, that's a switch. A circle with these arrows is an actual router. One arrow is a what? It's a hub. Okay, so this is a switch, this is a router, this is a hub. So that's how they represent them on Cisco devices or even on the test itself. So I'm going to get a few computers, let's say a few desktops. Let's focus on desktops. Don't you guys miss desktops? And I'm going to get four right over here. Then I let go, press escape. Now, of course, I use a straight through cable, or let's say for now, automatically choose. We know that this is actually a straight through cable, right? So let's say we go here to here and right over here to here. Give this a moment. Okay. So why are hubs obsolete? Why do switches are the ones that we actually use right now? Well, switches do not share bandwidth. For example, if the switch speed is 100 megabits per second, this PC gets 100, this gets 100, this gets 100, this gets 100. The hub speed is 100. Well, guess what? All of these devices, they are sharing 100 megabits per second because there's only one line of communication. In other words, if two machines are trying to transmit at the same time, they will collide. On the switch, on the other hand, all of them can be transmitting at the same time and there's no collisions. Why? Because each machine, each port has its own collision domain. So on the switch, I have 24 ports on this device over here. If I zoom in, I can see that I do have 24 ports and 2 gigabit ports. All right. So one thing to know is I have four collision domains over here. If I add the server, let's say right over here, and I hook up the server, right, to the switch, now I have five collision domains. So how do you know how many collision domains you have? You count how many connections you have on the switch. Well, on the hub, I'm going to get myself a server also right over here, and I'm going to connect right over here from the hub to the server. And guess what? How many collision domains do we have here? Just one. So the hub is one large collision. Why? Because bandwidth is shared on the switch. Every port is counted as a collision domain. How about if I connect the switch to the hub and I do automatically generated from here to here? And guess what? Crossover cable, because the switch is a smart hub. So, but the switch filters by a MAC address. That's why each one has its own line of communication. So, how many collision domains do we have now? One, two, three, four, five, six. Six collision domains. Totally. Okay, how about this? Let's say I remove the hub. Watch this. And I put myself a what? A switch over here. And there you go. So now I'm going to connect. Of course, I know it's crossover cable from here to here. So switch to switch, of course, is a crossover cable. Then I'm going to connect my end devices. Let's say automatically choose. All right. Just like this. And let me connect these over here and connect the server to the switch. So how many collision domains do we have now? We have four down here, eight, nine, 10, 11 collision domains. So I count the actual connections, actual cables, 11 collision domains. Okay, how about if I go ahead and I add a hub? Watch this. So I'm going to get myself a hub over here, and I know like if what kind of cable, it's actually a crossover from here to here. Okay. And then I get, let's say, maybe two devices. Let's say two laptops. One, two. And I make the actual connection to what? To the hub. How many collision domains do we have now? Well, one, this is one, two, three, four, five, six, seven, 8, 9, 10, 11, 12 collision domains. I don't count these because the hub is one large collision. As you see, that's a collision, which means every port lives in its line of communication. That's why nobody uses hubs anymore. Today is called switches. And before switches, we had bridges, which is software based. Switches are actually what? Hardware base itself. So that's a collision domain. So this entire network is one broadcast, which means they all belong to the same network. Why? I don't have a router. By default, a switch has one broadcast because there's only one VLAN, one virtual local area network. If I go to the switch and I go to the CLI, and then I do show VLAN. Look at this. I only have one VLAN. You see this? VLAN number one, and all the ports are a member of the VLAN. That's why I only have one broadcast, which means everybody belongs to the same network. So by default, switches only break a collision domain. Hubs do not break a collision domain. Routers, on the other hand, they break a collision and a broadcast domain. Watch this. Let me get myself a router here. Let's say a 1941 router. And let me get myself two switches. One switch here and one switch over here. And let me get myself a few computers. One here, one here, one here, and one here. Escape. All right. Let me put the actual connection, automatically choose for now. That's fine from here to here. I know everything is what? Straight through cable. So if I ask you this question, how many collision domains do we have here? The router breaks a collision and a broadcast. So I have one, I have two, I have three, I have four, I have five, I have six. Six collision domains. How many broadcast domains? Just two. One, two. You see that? Because each side belongs to a different network. This side, for example, is going to be on one broadcast, the 100.0/24. And this one is going to be on the 192.168.200.0/24. So I have two broadcast domains. You see that? Two broadcast domains. And I have how many collision domains? One, two, three, four, five, six. So the router breaks a broadcast and a collision domain. All right. Let me give you another image over here. Watch this. I'm going to get myself a router, let's say 4321 router, and I'm going to get a few switches. So let's say one, two, three. All right. And let's get one laptop here, one laptop here, one laptop here. And let me make my actual connection. So automatically choose router to here, router to here, router to here. Oh, it looks like I don't have much ports. Hold on. Let me switch this. Let me switch the router to another router. Where's the 2911? There's the 2911. So right over here. So I'm going to do automatically choose a connection. One, two. I could add more modules, of course. Three. And I'm going to connect here and connect this to here and this to here. So how many broadcast domains do we have? One, two, three. How many closed domains? Three plus four, five, six. Okay. So, in other words, if this machine sends a broadcast, the broadcast will not pass through the router. The router stops the broadcast. If this machine sends a broadcast, it will not pass through this interface. That's the job of the router, is to stop a broadcast. That's what I wanted to show you in this lecture, the difference between a collision domain and a broadcast domain itself. So we'll see you folks in our next lecture. Bye now.